Hello, my name is Chetan Joshi. I work at Panasonic Industry Europe. I would like to thank the organizers of Edge Impulse Imagine Event 2022 for giving Panasonic a chance to talk about smart sensors for smarter spaces. This is a talk that's going to be descriptive in nature of how Panasonic sees smarter spaces, and in particular, how one of our sensor solutions is poised to bring fundamental changes to how people detection can work in application with machine learning. So just to line out the talk today, the storyline will be revolving around the following topics. I start by giving a very short introduction to Panasonic industry. Then I'll share what smarter spaces mean for Panasonic industry and how do we see this market. In the next step, we'll talk about how machine learning is helping Panasonic and other companies in fine-tuning the people tracking applications. And finally, I'll cite some of the very interesting directions in which customers and engineers and enthusiasts of machine learning can take with Edge Impulse using Panasonic's Grid-EYE sensor. So let's start with a very short introduction to Panasonic. Panasonic is a very old company, a very experienced name in the sector of electronics. In 2018, we celebrated our 100th year in existence, a company founded by one of the legends of Japanese industry, Konosuke Matsushita. In Munich, in particular, we have opened up a Panasonic campus, campus from where I stand today and share this talk with you. And of late, this year, we have transitioned into a Panasonic holding company system wherein I, as Chetan, am part of Panasonic Industry, mother company with a sub-company sales entity, Panasonic Industry Europe. As far as the company itself is concerned, Panasonic is a very big name. We are a brand that is valued across the world, and we have good figures to show for it. So our consolidated sales were close to 56.4 billion, and of which almost 5 to 6% is reinvested back into R&D. And for a good reason in that, because we have a very wide product strategy, a product portfolio that's comprised not only of products that most of people are aware of in appliances, but actually on the industrial side of things, we have services and solutions which offer the entire solution, but then we can distill down layer by layer to offer either layer up systems or go down into granular details where we are able to offer devices and components with leading technology at the heart of these devices, right? Now, quickly jump to the topic of the day, which is smarter spaces. This is something that's really interesting for us. And why do I say so? So let's start by having a short overview of the market itself. This is not our data, but a market data that I picked up from a study that's linked in this slide. It's a market that is growing, and it's growing very steadily with a very impressive CAGR of 22.2% projected. So it's poised to reach around at $328 billion US dollars in due time. If you are to think about how smart spaces or smart buildings operate, you can segment them either by the means of applications. So you could think of a smart residence, smart hotels, smart hospital spaces, etc., and the others that you see on the screen here. Or you could go into these industries by components. So you could think of something such as building infrastructure management that could have components such as how do you manage parkings, or how do you manage heating and water distribution within a building, or mobility. Similarly, for security and emergency management, there is access control systems and video surveillance systems and safety systems. And finally, for energy, which is the hot topic given the kind of world that we live in, there's, of course, improved and always more efficient HVAC control systems, smarter lighting solutions, and interfacing with smart grid solutions. And as Panasonic, we are active in almost all of these verticals simply by the virtue of our size. Now, that's not the only reason why this is relevant for us. As a Panasonic industry, living space is one of our growth verticals. So we value the living space because it kind of offers growth vectors which are very relevant given our product portfolio. Those can be in home, in personal, and also in building infrastructure. And for today's talk, I would really pick building infrastructure because this is where we are kind of really focusing, projecting value with our technologies, with our products, with our solutions, with our services. One of the reasons to focus on this technology is also in our long-term vision. So we have a new program that's called Panasonic Green Impact, in which we aim to, by the year 2050, we want to reduce carbon dioxide emissions by more than 300 million tons, which is something that already amounts to 1% of current total global emissions. So by no means it's a small task, and we plan to do this by our products that we sell, but also the technologies that we develop and the technologies that we bring to the market, right? So that's the long-term vision, but that's not all. What we have instead, in terms of, let's say, shorter-term goals, is that we have certain tools that are at our disposal that kind of fit the bill of creating these new information-rich environments, environments that you and I expect to have in today's day and age. For example, smart desk occupancy systems or smarter airports to manage flux of crowds, or in hospitals to have some sort of continuous patient monitoring. And among different sorts of solutions that we have, we are able to address air qualities, wireless connectivity within a given infrastructure, people detection, and let's say people counting, tracking using either infrared or visual spectrum domains. So there's a lot of stuff that we have our access to that allows us access to basically treat this idea of being able to process the people-related information in a smart space. Now, having a product is good enough, but what's the catch here? So the catch is, for someone like Panasonic, it's very important to understand that whatever you call IoT today, the notion of smart, where the things are able to generate new information, new intelligence, it's not just Internet of Things. It's an iceberg of information that's by good engineering hidden in plain sight from the end user. And what would that look like in a smart building product? So what you have here, from top to bottom or bottom to top, interconnected layers. If we go from the bottom side, this is where Panasonic is certainly very, very active. So components, individual components, going right up from simple passive resistor, inductors, capacitors, to intelligent modules, to bricks, etc., etc. And then you build on top of these components to get a good quality hardware design. That's a good hardware design is often not enough, so you have to depend on good quality installation from your partners. And eventually you build on that in terms of software and data transports and good wireless networks, being able to handle data effectively, create data lakes, and do some intelligent data analysis. Finally, with the end goal of being able to derive some valuable business insights, right? Now, as you can imagine, for somebody like myself who works in Panasonic, very deeply into the components industry, there's a day and night difference between what happens on the hardware to what's actually happening on the business insights, right? And this is often also the challenge for Panasonic industry customers as to how they can bridge this gap, the day and night gap that this particular sector of smart building has to offer. So with that said, I would like to now pivot to a sensor to basically build around this example as to why machine learning can step in and help us in this context, right? So machine learning, of course, to an audience that's attending this conference is not a novel concept, but I would certainly like to approach this from a device vendor's point of view, or let's say a component vendor's point of view, which is often also very interesting, right? So now, what is Panasonic Grid-EYE? So essentially, Panasonic Grid-EYE is a very, very compact sensor. Something that you see on your screen could essentially fit on your fingernail, right? It's a sensor module that comes with an integrated lens and signal processing blocks, all been built into this very small assembly. There are multiple lens variants. For example, the ones that you see on your screen are 60 degrees and 90 degrees lens types. And all of this in a surface mount package. So essentially, it's highly suitable for, let's say, the modern manufacturing processes. At its construction level, these are 64 individual thermopile pixels that are arranged in a matrix of 8 rows by 8 columns. If you don't know what thermopiles are, so there is just a short description. Essentially, any incident infrared wave will be converted into some sort of voltage difference between the two electrodes of this thermopile element, and this signal can then be post-processed by converting this temperature difference into temperature data, right? This device unto itself is capable of giving up to 10 such images, each 64 pixels rich, in 1 second. And that, in terms of the overall data that it represents, every second you're receiving around 7.6 kilobits of data from Grid-EYE, right? This essentially translates for this small component to become a very, very low cost, very low resolution thermal camera solutions. We can say that it's a thermal camera with the catch that the resolution is not very high, but again, it does find its own applications. What are those application areas, right? So what we have seen in the past, that people use Grid-EYEs for either capturing the absolute temperature values, which can be used then to detect kitchen fire alarms, or have some sort of smart air conditioning, or smart ovens with smart algorithms that are able to detect heating patterns of food, etc., etc. Or else you could work with temperature gradient. So what's the temperature difference between two successive frames, and how that can be used to detect moving objects or moving people. That gives rise to business cases such as meeting room occupancy monitors, or hospital bed monitoring systems, or smart lighting systems, right? So this is great. As a component, if you can do all of this with this sensor, why is machine learning figuring in this if the solutions already exist? What we know as of today is that the Grid-EYE based solutions can measure temperature, they can detect presence of a person, they can monitor that presence if the person is motionless or moving in the sensor's field of view. It can detect the direction of the motion as well. And it can also count multiple number of people in a given field of view, right? It's great, but it's easier said than done, right? Why do I say this? Because Grid-EYE is essentially a transducer. It's taking a physical parameter such as infrared or temperature, and then it's converting it into electrical signals, and then you're just reading it over an I2C interface. It's plain simple data. You still have to process it, and you have to derive some sort of actionable intelligence out of it. And all of this needs to be done within the constraints of a computing hardware that can vary from one business case to the other. Some people can treat this data on a cloud. Others might want to treat this at the edge, at the device level, right? And while it's easy to do this at the device level, at the cloud level, at times it becomes difficult to do it at the device level, right? Why is that? Because these small microcontrollers that all of us are aware of, they are well suited to do these rule-based tasks, but to do these pattern identification and image recognition techniques, it's very hard to code traditional systemic programs, right? I don't want to preach to the choir, but this is why we are, as Panasonic, we are now focusing on machine learning applied to Grid-EYE. And why is that? Because as handwriting recognition shows us, it's an optimal technique to detect patterns when the variance is still high, but you can still go using machine learning, you can derive some sort of an abstraction. More precisely, why the reason we are also convinced is that in 2017 there was a study in which Google developed a neural network where they could derive some sort of reasonable inference of how a person would look from a highly pixelated 64 pixel image. What you see on your screen is, let's say, in the middle image is the inference, and the right hand side image is the ground truth. So that leads us to believe, or that led us to believe, is that what we can essentially also apply this to Grid-EYE, which is also fairly low resolution device, in order to derive some interesting results. And in a Panasonic sponsored study that we carried out, we developed a fully convolutional network where we used a camera data to identify ground truth, and also then treat or process Grid-EYE data to give rise to an ML model, the results of which I'm going to share with you in this video here. As you can see in this video, we have established two data sets. One of them is a camera acquisition, and the other one is a Grid-EYE acquisition. The camera acquisition establishes the ground truth, essentially showing how many people are in the frame, so that now updates itself to ground truth counter being 2, with the 2 people who are sitting around a desk. And the prediction counter that's running on Grid-EYE, which with the bounding boxes, as you can see, is also very reliably detecting 2 people around a table. Now, that led us to believe that there are many things that can be done, assuming in the market, assuming that there is a right tool chain that leads to easier adoption of such solutions. And this is where Edge Impulse comes into picture, right? So I want to enter into this last phase of my talk by offering some new possibilities, certainly some scratches that we have made on the surface, and I would like to share some early results with you, and provide you a context and a reason why you should investigate in Grid-EYE data exploited using Edge Impulse's toolchain. We have a new evaluation platform that's going to appear very soon. It's essentially an Arduino shield comprising of a Panasonic Wi-Fi module, PAN9520, and a Grid-EYE shield, which hosts different kinds of Grid-EYE. So it can come up in a Grid-EYE 90-degree lens, but also other sorts of Grid-EYEs. And we expect this tool to become a multimodal data acquisition device. When I say multimodal, it is possible to connect a camera to this device next to a Grid-EYE, which allows you to capture 2 different sensory informations and extract into one single data set. And this data set can be then used and analyzed by the community to deploy custom use cases, build your own data sets at a drop of a hat, and then deploy them to actual devices. Now, just to show you what can be done and why I personally am really impressed with Edge Impulse on this, is that we found Grid-EYE to be exceedingly, Edge Impulse to be exceedingly impressive as far as the speed of deployment was concerned, right? So just for prototyping and for testing at a DIY level, we were able to prototype something within an hour or so, including the building time. And also something that's very interesting from a multimodal acquisition point of view, so which is quick data labeling. So I'll start with the first one, which is, let's say, a hotspot detection example that we did. So we paired up a Panasonic Bluetooth module, PAN 1780, which is based on Nordic Semiconductor's NRF 52840. And we built up a very rudimentary setup, which had Grid-EYE connected as an off-the-shelf component, the 60-degree device, onto this wooden plank that you see. And we created a 4-zone setup, 1, 2, 3, 4, which allowed us to basically study which were the general areas within the field, and a hot coffee mug to identify a hotspot, right? What this essentially means for the experiment that we carried out is that by just simply moving the cup, we were able to decide which zone was an active hotspot. And within an hour, as I said, we could generate data, we could deploy it, we could do very quick setup. And what you see on your screen is a screenshot from a terminal application where you see for the top right quadrant, we have placed the cup on in zone number 3, and you have a reasonable inference value of 0.86, a very high confidence factor. Mind you, this is an unoptimized setup. So for someone who is just starting out in machine learning, doing this very quickly is actually very, very impressive, right? And what is furthermore very attractive for us is that we have a line of devices which is called which is Bluetooth or Wi-Fi and similar modules, microcontrollers essentially with small flashes and RAMs on them. And we were able to deploy this in a very, very small memory footprint. So this is indeed an attractive proposition, right? So this is not just an idea to throw around. Actually, there are very concrete business cases behind it. For example, hotspot detection in a kitchen setting. Something like this could trigger an alarm in case there is a fire hazard of some plate overheating or a oil overheating on a stove or something like this. And these applications do exist in the market today. And in fact, it's a growing sector indeed. And so, this was done within an afternoon. Where I also find a very neat application for Edge Impulse and its toolchain is, for example, the very famous by now, the FOMO framework, faster objects, more objects. This can really help us in getting these highly qualitative data sets ready, because as I said, a kit like Grid-EYE kit, where you have a Grid-EYE sensor and a camera sensor, you could essentially do quick annotation on a given image and try to match it with the ground truth on, so generate a ground truth on camera and then try to improve that on the Grid-EYE side, right? So all of this is right now at a very primitive level, and we are still trying to learn and explore on a daily basis, and we are only pleasantly surprised by what we find. In case you're interested in knowing more about this, I would request you to please contact us at grid-eye@eu.panasonic.com. I would therefore veer towards the conclusion of this talk. And in conclusion, the only thing that I want to say is that the technologies that we are bringing to the market as of today, they come from a very good place in heart as someone who understands the manufacturing industry, the manufacturing engineering really well. And we also see that only having good quality components with almost let's say very low failure rates or having a good hardware design engineering is not enough. Today, the complex layered products actually need to have a value chain through and throughout the life, the design cycle of the product. And I would like to end by sharing this screenshot that was shared by Mihailo, who's the sales director for Edge Impulse in EMEA in Europe. And he said something about it's all about balancing the tetrahedron. So that is what is good about manufacturing engineering. Right? So as long as you are able to balance this delicate let's say, equilibrium that exists between doing a product at a good cost, at a high quality, fast enough, and being still very agile and flexible to design, then you have hit the nail right on the top of its head. So with this, I'd like to thank you for your attention. I look forward to receive your mails, queries, and if you have any questions, please feel free to raise after the talk. Thank you.